This tiny little sliver of blue light along the edge at sunrise, that's the atmosphere. Everything protecting us from the world outside.
Pictures are so much more communicative to the brain. The brain can see much more in a picture than it can see in data. So showing in pictures the evolution of the Earth, just to see over time how humans have been changing the Earth, is just an extremely powerful way of communicating information.
In green, you see places that have had the same amount of light over time. In blue, places where the amount of light has decreased. And in red, places where the amount of light has increased dramatically. Right away, you can see an interesting disparity between the long-developed world and the developing world. You can actually go into even the developed world and start to see interesting effects, like suburban explosive growth. In a large city, where the city center has had light for a long time, but in the recent 20 years, you have a massive expansion. That kind of expansion, as we all know, has significant consequences on transportation, on carbon dioxide, on the way we live. And so it's important to understand these dynamics. And the first place we're going to go to is Lagos, Nigeria.
Okay, so in Lagos is the largest city in Nigeria. It went from less than 1 million people to people debate whether it's 20 million, 15 million, somewhere over there. So you can see over time the change in the size of the city. Here we are in 1984. You see the city in 1984. If you go instantaneously to 2015, you see the expansion, the enormous expansion of the city. The city just expanded enormously to its hinterland.
I'm going to go to the city of Pittsburgh. For the last 20 years, up until about a decade ago, the city actually lost population. But even while Pittsburgh lost population, it grew. And as with many cities, it grew in the suburbs. So the city center here lost a great deal of population at the confluence of the Monongahela, Allegheny, and Ohio rivers. At the same time, if you look here, with your eyes, you start to understand a development, a transition from forest land to developed land. This is very interesting because the developments here are in the valley of the Ohio River. The valley of the Ohio River is precisely where we have an extremely large amount of pollution. Over the course of the last decade, large densities of population formed precisely around the industrial zones inside of the river valleys. So one of the interesting aspects of urban growth in this case is that the industrial area and the residential area merged because the residential area moved. So planning was not carefully thought out. As a result, this area in Pittsburgh here has the highest asthma rate in all of the state of Pennsylvania, which in turn has quite high asthma rates compared to the rest of the United States. And it's very interesting to think about this idea that even when a city shrinks, you can actually have degraded health.
So now we're going to move to another city that grew enormously. We're going to go to Shenzhen. It's a city that was not really there, was maybe a village of 40,000 people, and it's now a metropolitan area of some 40 million people.
So here's a picture in 1984 of the 40,000 person Shenzhen. And I'll just jump you to 2015, Ricardo, so you can see the growth first. One of the interesting ways to also view this information is by looking at the overall loss of forests over time. You'll actually see zones in which industrialization, in red, has significantly degraded or decreased the amount of forest cover that exists. So you can start to see where urbanization is replacing forest with industrial activity. One of the interesting additional effects, of course, as we densify people, is we have to figure out how to feed. So let's zoom in for a second on Dalian and look at the development of massive farming around fish. So I'll go to 84, and I'm going to go all the way to 2015 first and show you all these rectangles here. These are all agriculture. It's all fish. And that is because you have an incredible explosion in population. You need a way to be able to create protein for that population. And you can actually see it develop over time, and it really correlates well with the growth in population in China as a whole and in Dalian in general.
So it is both a positive and a negative story of how different forms of human settlement have different impacts on the world.
This is another city that has grown by leaps and bounds in population. But interestingly enough, it didn't grow by leaps and bounds in area because the growth happened with densification. These green lines are protected areas. And you can see the evolution of the city while still protecting the green areas. A different strategy is the strategy, say, followed by Brazil when they decided to move their capital from Rio de Janeiro to inland and upward so as to populate a new area. It's a very planned city. Nourbakhsh came up with a bunch of ideas on how cities should be and how they should be planned. So it's not a very compact city, on the contrary, it's a very extended city. But if we move a little bit northwest of here, where Nourbakhsh did not necessarily plan, you'll see the changes in land use. So
all that red, that's all destruction of tropical rainforests and replacement by farmland. Is that right, Ricardo?
Yeah.
And you can see the extent of it is dramatic. You're looking at an area now more than 400 kilometers wide, and across that entire area you can see both the interplay of loss of forest and the fact that in some cases the protected areas are able to stop it to some degree. But you can even see places where the protected area does not save the game. So as a policy tool, you can see how this visualization can help governments, municipalities understand where protection is working and where they need to redouble their efforts for protection to work effectively.
Humans have always been limited by the environment. It's just that we have become better and better of solving the limitations that the environment imposes on us. That's why we are 10 billion.
I was going to go to Karlovy Vary next.
Well, Karlovy Vary is the Czech name for Carlsbad. In that whole region, agriculture has shrunk and forests have come back. All the blue is a forest coming back. It's all farming over here. And then over time, they leave the farms and the forest comes back.
You can see right around here the transition begins. And you have significant increase in forest recovery. There's a satellite, a wonderful satellite we have access to, that shows every fire across the earth. And if we think about industrial activity and human activity, fire is a really interesting indicator of that. If you turn your attention to Africa, for example, we can really start to see seasonality in the way land is cleared, which goes right back down to the nutrition question again. How are we going to feed all the people on Earth? In this case, a very inexpensive way to create soft grasses and to be able to clear the land for planting season is fire. You can even see up in Asia the way the fires seasonally spread upwards away from the equator, precisely because planting season times vary based on how far you are from the equator. But then we can also see direct industrial activity, resource extraction. Look along the Gulf. These lights don't flicker. They don't move seasonally. They're always on. So here you're seeing flaring activity. Then you have flaring activity that can be pretty depressing. So let's go to the United States. Look, there's 3 major kinds of industrial activity that have very bright spots, some of the brightest spots we have anywhere. Here in Texas, what we're seeing is energy extraction and flaring resulting from that. And up in North Dakota, which had very clean air once upon a time, you have a massive amount of flaring. And if I remember correctly, something like 30% of the carbon, 40% of the carbon extracted from the ground is today literally burning and being released because there's no infrastructure for preserving it and transporting it. What's remarkable here is it's a visualization showing you where carbon dioxide is put out into the atmosphere, loaded into the atmosphere by human activity. As with anything, by having many layers of data, we can tell the complete cycle story. This CO2 release is, as we all know, responsible for massive increases in the overall density of carbon dioxide in our atmosphere. And as the CO2 is reabsorbed back into the ocean water, it acidifies the top layers of the water, and that acidification is going deeper and deeper. In pink, you're seeing every example of coral, which is exciting already because we can zoom in and show that to you. But as time plays, you can actually see bleaching happening around the world, which is heartbreaking. If I go to Florida, 1999, 2007, you see, if I go back to 99, there's almost no bleaching here. I go to 2015, there's been massive bleaching around the Florida Keys. And that's all because we've reached a tipping point where the acidification, the chemistry of the ocean, the temperature of the ocean no longer support the kind of hard coral regeneration and sustainability that we wish for. And this is getting worse and worse over time. It shows you the expanse of area across which our ocean is simply not fit for the kind of biodiversity that we need. And this has direct implications, not just for sightseeing, for tourist trade, and therefore for economic commerce in places like Malaysia, but also for nutrition, because the fish can't exist in the acidified water well. And so they naturally move away from the coastline. So fishermen have to go further out. They can't bring in as large a haul. And again, you have a nutrition problem that in turn leads to intense pressure on productivity and urbanization.
The more we understand our impact, the more we will be able to behave in such a way that we minimize it.